Hello guys, welcome back to my channel Data Science with Gagan. So today in my video I'm going to share a computer vision project where we will be performing object detection using Yolo V10 model, which is the latest model in the Yolo V family. So as similar to previous videos, first we will go through some concepts and then later on we will look into the coding part where we will see how can we do for inferencing using pre-trained models and how can we train Yolo V10 model on our custom data set. Yeah. So here in the screen you can see this is going to be the content for this video. First we will see what is YOLO and how it works, and then we'll look into the YOLO V10 architecture, and then we'll see how can we do inferencing using the pre-trained models using Python, and then we'll see how can we train YOLO V10 model using our custom data set. Okay, so let's start with YOLO. So what is YOLO? So YOLO stands for you look at once. So it takes the entire image into a single instance and then it predicts the bounding box and the class probability for the object. And the biggest achievement of this YOLO models is that it is the fastest model as compared to other object detection models. Here in the screen you can see it can process 45 frames per second, which is quite fast, right? So now let's see how it works. So first YOLO takes the entire image into a single instance and then it divides the image into into m grids. So let's say an example, it has divided a image into 3 by 3 grids, right? Where each grid will be responsible for the object detection, right? So basically it applies image classification and localization on each grid, where YOLO then predicts the bounding boxes and the class probability for the object. So basically it checks each and every grid in the image, and if it found any grid which is having any object, then it returns an array for that particular grid which is consisting of object, and the information is class probability, center x, center y, height and width, class 1, class 2. So class probability means probability of that particular object in the grid. Center x, center y, height and width are the bounding box coordinate. Class 1 and class 2 means if it founds class 1, then it will be 1 for class 1 and 0 for the class 2. And if it found class 2, then it will be 0 for class 1 and 1 for the class 2. So this is how YOLO works. So now let's have a look at YOLO V10 model architecture. So in the screen or in the diagram, you can see this is how YOLO V10 model architecture looks like. Basically, it is consisting of three major components: backbone, PAN, and then head section. And head section is consisting of two heads, one to many head and one to one head. Where and in this architecture, your backbone is responsible for the feature extraction, where it uses the enhanced version of CSPNet, and CSPNet is stands for cross-stage partial network. And then we have a next section where we used to aggregate features from different scales and pass them to the head section. And for the aggregation purpose we use PAN, which stands for path aggregation network. And as I told, in the head section we have two head, one to many head and one to one head, where one to many head generates multiple predictions per object during the training time, which improve learning accuracy. And then we have one to one head which generates the single and best prediction per object during inferencing time to eliminate the need of NMS, and NMS stands for non-max suppression, right? So this is how YOLO V10 model model architecture looks like and works. And then here you can see like we have a 6 different variant of YOLO V10 model, and these variants are as per the sizes. So we have nano. First one we have nano version, then we have a medium version, then we have a small version, then we have balanced version, then we have large version, and then we have extra large version, right? And as we move towards the large version, the accuracy will get increased, but the prediction time or inferencing time will get decreased, right? So this is all about the YOLO V10 model. So now we will look into the inferencing part, where we will be using pre-trained model weights so we can perform object detection in the live video. So we will see how can we do it. So to do object detection using Yolo V10, we need Ultralytics library and supervision library. So we need Ultralytics library so we can have access to Yolo V10 model that we have downloaded, that we will download. And we need supervision libraries so we can annotate, so we can do annotation in the live video, means so we can create bounding box on the basis of results that we will get from the model predictions, right? So you will have to install these libraries. Once you will install these libraries, you can import them. So I have installed them. Now in the 39th cell I'm importing them, and then using the wget library, I'm just downloading all the pre-trained model weights from n to x, right? So here you can see I have downloaded all the weights. So now the thing is, right, now it depends like now which model you want to use here, right? So so for that thing, so what you will have to do, yeah, so you will have to give model. So here you can see like from the analytics, I am importing this class Yolo V10. So using this class, what I will do, I'll be loading this model weight. So what I need, I just need to give this path. So here you can see like it has loaded the path. So once you will load this model, you can use this model for the inferencing part. So let's see how. So let it run. So here you can see, right, like it is showing me as person. Then I have two beds, right? So one bed it is showing bed, and somewhere for the second bed it's fluctuating between cows to bed. So it is based on the model that we are going to use. So it depends on your system requirement. If you can use the extra large model, then you can use, but it's again on your system requirement. So let's say like I'm just showing the bottle. So for bottle, it's showing bottle. If let me show remote, okay, then it's showing remote for the remote. Then I guess it's good, right? So let me bring an other object. So let's say like let me show you the pen. Okay, so for pen it is showing toothbrush. Okay, okay, let's see. So let's see like what if I use X. Okay, I'm using the extra large model, right? That's why. Okay, if you will use this, right, and model, then you will see the performance difference. So here you can see, right, the model is the video is quite good, the speed is quite good, but you can see, right, the predictions are not that much accurate that we had for the extra large model. Yeah, it's not able to detect this pen. Okay, yeah. So here you can see, right, first in this 44 cell, right, first I'm capturing the video, and then I'm just reading each frame, and if it is written, then I'm breaking out this loop. Then then I'm giving this frame to this model and getting the results. And the basis of this results, right, I am drawing all those bounding boxes using the supervisor library. And then here you can see, right, if I press this Q button, right, then it will what it will do, it will quit the video and come out. Once we will come out, now we have to release all the resources, right? Then we are releasing all the resources using cap.release and cv2.destroy all windows. So here we saw, right, how can we do the inferencing using the pre-trained model weights, and you can use any of the model weights here for the inferencing part. So till now we saw how can we do inferencing using Yolo V10 pre-trained models. Now we will see how can we train Yolo V10 model on our custom data set. So for that purpose, first we will collect some images using CV2, and then post that we will do some annotation, and for the annotation purpose we will use RoboFlow. Once we will do annotation on those images, we will use those annotations for the training part. So yeah, let's start with the image collection part. So here you can see I have written this code where we will see in the image where we are capturing the frame. So to capture the frame, once we will press the S button, it will save the frame, and we will have to show some object for that particular frame. So let's start. So here you can see I'm importing these libraries, and this is going to be my path where I will store all the images. So let's start. So yeah, now let's start with portal. Now like we will do it at different direction, at different angle. Now let's do it for remote. Now those models were showing toothbrush or pen, right? So let's do it for pen now. So now let's suppose I have to. So I have collected some images. So let's quit it now. So to quit it, we'll have to press Q. Sorry. Yeah. So here you can see I have saved, or I have collected 46 images, right? So now what I will have to do, I will have to go to this RoboFlow website to do the annotation part. So to start to begin with annotation, we will have to do the sign in. So I have my account here using my Google. So I will just do it. So here you can do any kind of like, so here you can do multiple kind of annotations. Once you will do the annotations, here you will get the option. You will get the option for to perform the augmentation, right? Like where we will where we use to generate some random data from your data, right? So let's start. So here you can see like I have to start new project here. Let's say object detection. And then here I have, let's say for now, like let's create one class and we'll create another other class later. Let's say first class is bottle. Let's start, create public project. Now once you will do it, right, you will have to select the folder where you have all those images. So I have those images in my location and data image. So upload. Okay. So once it will upload all the images, you can see here. So here you can see, right, all the images are here. So then what you can do, you can do save and continue. So let's wait. So here you can see like you will get the multiple options, like like if you want to do, if you want to use any model, so you can do a automation, automated annotation. So you can select this option, start auto label, and if you want to do your annotations by yourself, then there will be an option for manual labeling. So I'll do it manual labeling. Yes, so I'll do it myself. Here you can see like I have all the images here, but the thing is that previously I created only one class, right? So I'll have to create other classes as well, right? So what I'll have to do, I'll have to go to the classes. So here you can see, right? Okay. So what first I'll give portal, head class, and then I'll add one more class for pen, and similarly we'll do it for the. Okay, now we have three classes, right? Now what we will do, we will go to the now we have this, right? So we will do start annotating. So here, right? So we will have to annotate this, right? So now we have completed all the image annotations. So the count which is here you can see, right? For unannotated you can see as 0 count, and for annotated you can see all the 46 counts, right? So once we will do all the annotations, we can add all these images to data set. So you can click on this. So here you can see like now how what should be your split. So once you will do it, right, so here you can manipulate it as per yourself. So here I want to take, suppose I want to train my model on 80% of data sets. So here you can select, I've set it as 80% and validation and test as 10%, right? So when you will set those, right, so here you can see what will be the count. So you will use 37 images for the training purpose, and for 4 images for validation and 5 images for test purpose, right? So once you will select this, it will create the data sets, and you can see your data set inside the dataset tab. So once you will do it, what the things then you will have to go to the generate, where here we are going to do augmentation. So, and once you will come to this tab, generate tab, you will have to press the continue button. Once you will press the continue button, you will go to the augmentation tab, right? So here you will have to decide what augmentation you want, like what kind of manipulation you want to do with your images. Whether you want to rotate your images by any angle, or you want to do, or you want to apply any filter on your images. So here I am going to just rotate every image is by 19 or 20%. So let's say this I'll do rotation by 20 degree, and then I'll do apply. And also, along with this rotation, right, what else we want to do. So here you can do right now, along with that I want to do I just want to increase the exposure of, let's make it blur. So let's suppose if camera gets blur, right, if image gets blur, then it will be easy for the model to identify the object even in the blur image or blur frame. So let's do apply and then continue. Now it will ask you, right, what count you want. So let's say here it's giving us 3x as default. So let's select it as it is, and click on create buttons. So here you can see we will be having 111 images for our training set, right? Once you will do, what we can do, we can export data set from here. Now while exporting, right, what you will have to do, you will have to select your data format, right? So we will be exporting Yolo V8 format, because Yolo V10 model uses the same data format for its training. So, here you will get two options. Either we can download the annotation in the zip file, or you can, what it will do, it will give you the code using which you can directly import your data set into the code, and you can use that data set for the training purpose. So we are going to use this code. So here, let's see. So it's zipping the file, and then it will return you the code. So you can use this code. So now we got the code from the RoboFlow, so we can access our data set that we have created, right? So now once we will do all those things, we can go to this Google Colab notebook, which is from the RoboFlow itself. So here you can see, here we are doing the same things as we did in the local system. First we are installing all the libraries, here you can see that we are installing this, right? So instead of, we can use Ultralytics directly, right? And we are installing supervision and RoboFlow. So we are installing RoboFlow, so we can access our data set that we have created on RoboFlow. And then we are downloading all the pre-trained model weights from N to L, right? And then once we will download all these model weights, right, we can access them. So here in this cell you can see, right, using first here you can, in this cell, right, so here, right, the code that we got from the RoboFlow, using that code here, so here can, we are downloading our data set. Yep. Now the thing is, right, so we got the data.yml file, right? So we will have to make some changes here. So let's copy it, and here you can see in dataset object detection. So this is how your data looks like. All the data related to test will come under the test folder. Training data will be under the train folder. Validation data set will be under the valid folder, and here is your data.yml file. So here you can see, right, here we have to specify all these data set path, right? So we have done this. Let's save it, close it, and here is your command which we will use for the model training purpose. So let's say, now I'm just reducing it as create. and let's keep it as 100, and we will retrain this nano model on this there. So let's see, let's train it. Once we will get the trained model, we can download that model from here to our local machine, and then using that model we can do the inferencing parts. We will see it later once we will done with this model training part. Okay. So here you can see, right, like the optimizer that we are going to use the Adam with this learning rate, where our momentum will be 0.9. And the one more thing that I forgot to mention, like before running this code, you can select or you can change your runtime from CPU to GPU. So once you will select the GPU, you can see the training speed will get increased. So here you can see, right, MAP mean average precision at 50% and for 50 to 95%, right? And what is the recall? Let's see what we get in the end. So here you can see the R model has been trained on our data sets, and these are the numbers. And you can see, like what MAP we are getting on 50, and what MAP we are getting between 50 to 95, and what recall we are getting. So these are the, like but for this time, like this number looks good, but you can increase number or you can improve these numbers by doing multiple things, like you can select any other models, like you can select any medium size model instead of this nano model, or you can use a balanced model which is having which shows good accuracy instead of this nano model. And also you can manipulate around some parameters, like what should be the learning rate, what should be the learning rate, and what batch size you want to select there, and how many epochs you want to you want this model to train, right? So these all things you can do to improve these numbers, but for now, like for this demo purpose, these numbers looks good. So here you can see, right, so let's connect. So here you can see, right, and like let's see like what confusion metrics we are getting. So here you can see, like this looks good, and okay. So now we have this model trained, right, trained model. So here you can see inside this run detect, and we have this here we have this model run detect train. Okay, so inside this folder you will get this weight inside the weight folder. So here you can see the best, so you can download this. So let's download this. So it's getting download. So once it will get download, we can use this model for the inferencing purpose. Then let's see, like what we get from this model, whether it's able to identify all the object in the video or not. So it's downloaded and download, and we can paste it into our directory on which we are currently working on. Mhm. Let's say we have this file here, and now let's this file. So here you can see, right, here we want model path, right? So we have this best.pt, and once let's load this model. We have loaded this model, and we can use the same code as we used above for the inferencing part, where we will first capture the frames and then we will feed that frame to the model, and model will do the predictions, and based on the predictions we will use supervision to do all the kind of annotations. Let's see what it does. Yeah, so it's remove portal. Okay, okay, now let's see if it is able to predict pen. It's a pen. Okay, somehow it is able to predict the pen as pen, but okay, we can see, right, like our model is able to predict all these things, and it means like it's our model is able to detect all the objects in the image that we have trained on. But like we can increase this performance by even collecting more images for each object, and by select or by using any other model, and or by playing around some parameters, right? So we can improve this further. So let's close it now. So now till now we saw, right, what is YOLO and what is YOLO V10 architecture, how it looks like and how it works, and then we see how can we use pre-trained model for the inferencing purpose, and then how can we create our own, how can we train YOLO V10 model on our custom data set. So this is all about this video. In the next video, we will see how can we do object tracking, like using YOLO V10 model, and we'll perform deep shorting, right? We will use deep short and YOLO V10 model for object tracking. So see you guys in the next video, and stay tuned. Like in the next video, like it's going to be a very interesting topic where we will track all the object in that frame. Yeah. So this is all about this video. Bye guys. See you in the next video. Bye. Before leaving this video, please do like and subscribe my channel to keep me motivated so I can create many more videos for you guys on data science projects. And please don't forget to press bell icon to get the notification for the next video. Thank you guys.